While the last people are getting in, let's get started. And so there's one more. Are we okay? We're good. We're on. So thank you, everybody, for coming today, because we're going to dive into one of the aspects of life here at Cogswell, which is all about programming, all about building things that are intelligent. And we introduce everybody. Everybody has to learn Python. That means artists learn Python. So we have engineers have to learn how to sketch too. But part of it is not just knowing how to do things in Python, but understanding how computers do things, how they get programmed, what they can do. And one of the great ways of showing that off is using robots, using the software to then be applied to making something do something, right? So one of our instructors, Irv Kalb, has just recently published a book. Where's the book?
It's part of my talk.
It's part of your talk, but I get to show you off. Learn to program with Python, right? So it's available online at Amazon. Buy it today. Irv, you wouldn't say that, right? So, yeah, please buy the book. But it basically goes through the way it's taught here at Cogswell. And so you get a sense of that. You'll get a sense of Irv. Irv, it's all yours. Irv Kalb.
Thank you. So, my name is Irv Kalb, and I'm an adjunct faculty member here at Cogswell. Let me just give you a little bit of background as to who I am and so you know where I'm coming from. I have a bachelor's and master's degree in computer science, and I've worked as a computer programmer for over 30 years. I worked for a number of high-tech companies in the area. I worked for Apple Computer, I worked for Siemens Medical, and then I went off as an independent software consultant, and I created my own huge company. The company was called Furry Pants Productions. Actually, it's not a huge company, it's just my wife and me. And what we did first was we created 2 kids CD-ROMs. So we created and shipped these 2 kids CD-ROMs, all about a boy and his dog. The company was called Furry Pants Productions because no matter what the temperature is, dogs and cats always have to wear furry pants. So I've been teaching software development for the past 6 years. I teach here at Cogswell. I've taught here for 2 years. I've also taught at the Art Institute in Sunnyvale for about 5 years. And I teach a night class at, I teach night classes at UCSC, UC Santa Cruz, Silicon Valley Extension, which is confusing because it's actually right here in Santa Clara. And what I do is I teach Python. So I'm a Python instructor. As a historical side note, and in my spare time, I've also worked as a mentor to local robotics teams with both of these things, and I'll be talking more about robotics later. As a side note, I was very involved in the beginnings of Ultimate Frisbee. That's me actually back in New Jersey with Ultimate Frisbee. I was the captain of the high school team that developed the sport. And because of that, I have a bad back, so I have to sit down every once in a while. Unfortunately, I've had a back injury. So please excuse me if I sit down for most of the talk. So one of the things that's unusual about Cogswell is that we teach a number of different technical sciences here. And excuse me, the official name of the school is Cogswell Polytechnical College. And polytechnical means that we teach a number of different areas. We teach digital art, digital audio, game design, and a small number of people, a small percentage, come here to study computer science. But that's not the main thing that people come here for. So the thing that's unusual is that everybody, all students, are required to take Python programming. And the question that I get asked all the time is, why? Why is computer programming required at Cogswell? Well, it's required for a number of reasons. And the main reason is that computers are becoming more and more parts of all of our technical lives. No matter what technical area you go into, you're going to be working with computers or working with people who work with computers. So we're not trying to turn everybody into a programmer. That's not our goal. But if you're going to go into a technical field, the more you understand about computer programming, the better off you'll be. Further, even if you have a basic understanding of the work of computer programmers, then you'll understand more about programmers' environments and the kinds of things that would make you work better with programmers. And I'll give you some examples of how that would work, even if you're an artist and you want to work with programmers. I'll give you some examples of that later. We have a dean named Jerome Solomon, and I asked him this question. I said, why do we teach programming here? And he said, we teach both sides of the brain at Cogswell. And then he went on to say that our industry advisors, the industry advisory board that guides the school, has said that having a basic understanding about computer programming helps students find jobs. We've found this out over many, many years. So let me talk a little bit more about the course that I teach. The course that I teach is called the Application of Quantum Physics to the Development of the Nuclear Battery. Oh, wait, no, that's not my class. No, my class is just called Software Engineering 100. It's essentially an introduction to programming using Python. And as I said, we're not trying to teach people to be programmers, but we do want people to understand the concepts behind programming. So then the question comes up of why do we teach Python? Well, there are many, many languages out there, and we decided on Python for a number of reasons. And the main reason, the first reason, the best reason, is because of the language's simplicity. It's a very simple language to learn. And as a good example, I'm going to actually write some code here. So when a programmer comes up with a new programming language, if you want to learn a new programming language, there's a tradition that you write a program called the Hello World program. Anybody here written Hello World? Okay, so you know what I'm talking about. So I'm going to do this live and in color here. So let me get out of that. I'm going to bring up my Python environment. My Python environment is a thing called idle. And I'm going to write the Hello World program right in Python. I hope I remember all the details. Let me stretch my fingers here. Here we go. Okay, here we go. I have to remember all the little things. I have to say print, quote, hello world. Done. Okay, so that is the Hello World program in Python. I've written in the entire thing. So you can see how simple it is. It's just the word print and some string, and it prints it out. So as a comparison, let's see what you would have to do if you wanted to do the exact same thing in some other languages. Now, this is not meant to bash other languages, even though I don't really like other languages, but that's not the point here. The point is, what do you have to learn in order to do this in other languages? So here's the Python world, print hello world, and it writes out hello world. Let's do the same thing in C, single most popular computer programming language in the world. And if you're not into programming, look at all the stuff that you have to do here. Pound, include, bracket, stdio.h bracket, int main parentheses void, squiggle, printf, parentheses, hello world, /n, quote, parentheses, semicolon, return 0, semicolon, squiggle. Great. So C is a very old language. It's been around for 40 years, maybe 45 years. Some number of years ago, there was an improvement to C. It's called C++. Added more power to C. So let's see what you'd have to write if you wrote the same thing in C++. Well, pound include stdlib facilities.h, int main squiggle, count less than, hello world, /n, quote, semicolon, return 0, semicolon, squiggle. Whole bunch of stuff. Another popular language is Java. Here's what you have to write in Java to do the exact same thing. Public class hello world, squiggle, public static void main strings, bracket, args, parentheses, squiggle, system.out.println, hello world, squiggle, squiggle. That's what you have to write to do the exact same thing in Java. As a reminder, there's Python. So this is just a simple example, but Python is designed this way. It's designed from scratch to be friendly. It's designed from scratch to allow you to worry about, to allow you to get things done quickly without having to worry about all these strange things in the syntax of the language. C and C++ and Java require you to understand things like having a semicolon at the end of every line, having blocks of code inside these squiggles. Python just eliminates those things. When they designed that language, they just said, these things are not necessary anymore. We know enough about how to build languages so that we don't have to have those things anymore. So the first reason we teach Python is that it has a simple syntax. It's much easier for new students to understand, and especially students who are not planning on being computer science majors. So they come in and they can understand things like a print statement. That makes a lot of sense to people. And it's much easier than having to remember all the details and what I call the minutiae of these other programming languages, the semicolons, the squiggles, all the different things you need to do. And if any of you have a programming background, you know that in the other languages you have to declare your variable types. In Python, Python has a simple rule that any variable can be any data type at any time. Very simple. You don't declare variables at all. So, first reason is the syntax. Much easier for students to understand. The second reason, and this is good for any parents in the room, so parents who buy software, the cost of Python, $0. It's absolutely free. So Python is not owned by a company. Python is it's owned by a group called the Python Software Foundation. And it's a free thing. It's a downloadable project. It's an open source project. In fact, if you want, you can get the source code to Python and look at it yourself. And in fact, what we do in my class is all the computers in the school, every computer in the school has Python downloaded onto it. On day one in my class, I teach students how to get it from a website called python.org. You download it for free, you run it on your own computers. So the students can run it in class or they can run it at home. The third reason why we teach Python is it's cross-platform. The environment that I'm running, the thing that I showed you, this thing called idle, it runs on a PC, it runs on a Mac, it runs on Linux. If you're into Linux, that's fine. From the user's point of view, from the programmer's point of view, the environment, once you get into the environment, the computer doesn't matter. So if I run it on a Mac, I run it on a PC, it's exactly the same. In fact, I'm a Mac guy. This is my Mac that I brought in. I do all my development on a Mac. I do all my samples on a Mac. I put them onto a flash drive. I bring them into my class, plug it into the PC, and it just works. So all the code that you write is completely cross-platform. There's no concept of what platform you're running on. And that's built into the language. Very, very nice thing. Additionally, so the next reason is that Python is actually used in many industries. It's used heavily in a number of different industries in both technical and creative fields. So it's used to solve problems in biology, chemistry, financial analysis, numerical analysis, robotics, as we'll see. It's also widely used as a computer administrator's tool. You may not know this, but the first version of Google was written in Python. Sergey and Larry Page wrote Google in Python. It's been changed since then to speed it up. In fact, a number of Google's current applications are written in Python. And additionally, there are some art programs like Maya, and I know there's another one, I can't remember, Blender, I think it's called. They allow you to write extensions to those programs in Python. You can write these things called filters that I know nothing about. I'm not an artist at all. But if you're an artist and you know about filters, you can write filters in Python to extend those programs. And the final reason is Python can serve as a gateway drug. I mean a gateway language. So if you learn Python first, and that's what we teach here first, then if you understand the concepts that I teach and the other teachers who teach Python teach, if you understand the concept of variables and loops and if statements, then moving to another language like C, C++, or Java is much easier. It's a matter of syntax, of learning what the differences in the language are. But I can teach the basic concepts in Python, and then you can learn other languages after that. And we're not alone. So there was a survey that was done, it was reported in the Association of Computing Machinery. This was in 2014. There was a guy who took a look at top 39 United States computer science departments that all teach an introductory course in computer science. And look what's number one. Number one language that they use is Python. Next is Java, and then a bunch of languages that you may not have heard of, MATLAB, Scheme, there's C and C++, and Scratch. This was done in 2014, and if they did it again today, I would expect that Python might be higher, because it's been shown that using Python as an introductory language is a very good language to use. So let me give you a quick overview of the class that I teach, what types of things you might see in the class if you took the class. So the class, again, is SWE 100, Software Engineering 100. It's an introduction to Python programming. It's required for all Cogswell students. The class is divided into 3 parts. It's very unusual. I do this in a very different way, and I do this on purpose. The first third is basic programming stuff. So I talk about variables and assignment statements and function calls, building your own functions, loops, all the basic constructs that you need. Then I have a midterm. So I have a midterm very quickly into the class. So in fact, today is the end of the 4th week. Next week is our midterm. The second third is more advanced programming. And here I get into concepts like lists and other data structures. And I get into strings heavily. I get into string manipulations. And going along with strings and the ability to manipulate strings, we go through the ability to write out to files, write out text information to files, read text information back in from files. And then we go further into strings. We wind up using Python to reach across the internet and get data that's available from servers. So I teach how to use a thing called application programming interfaces, APIs. I give examples of how to go out and get stock data from Yahoo or Google, or how to get information about weather across, from any city in the world. You can sit at your computer right here and find out weather data from anybody by writing a couple lines of Python code. Then as a short diversion here, all the material that I cover up to that point, oh, I'm sorry, and then I give what I call a summary exam. It's really my final exam, but I give it at the end of the second third of the class. And that's just to make sure that everybody's understanding all the material that's going on. But I took all that material and decided to write a book, because I couldn't find a book that I thought was good enough. I was looking for a book for years. I've been teaching this course, but I developed my own curriculum because I couldn't find a book that I thought was good. So I wrote a book, and here it is right here. It's called Ultimate Fundamentals. Oh, wait, this is my first book. This is Ultimate Fundamentals of Support. Sorry about that, wrong book. Here it is right here. It's called Learn to Program with Python, and this is essentially my course in a book, but it's more than my course. It goes into more detail than I can go to in my course. But I left some stuff out because I left out the homework assignments. So if you take my course, you get to go through all the homework assignments and all the tests. Those are not in the book. But I'm very proud of the book. I think it came out very well, and I hope to sell millions of them. I hope to sell more than Harry Potter and retire a millionaire. So the third part of the class. Oh, there's my book, sorry. It's available on Amazon, Barnes & Noble, and better bookstores everywhere. The third part of the class is project-based. So many of the classes here at Cogswell are project-based classes, and that's what I do. After I've taught you what I think you need to know about writing code, then your job is to propose, build, and demo a software project. So I give examples of potential projects that I think that students should be able to do after having the introduction that I give. And then it's their job to write up a proposal and make a pitch. They have to come in and talk to me about their proposed idea. I approve it, they go off and they start programming it, and for the rest of the semester, I run around like crazy helping everybody out and fixing bugs and making suggestions, and it works out very well. In the last week of the class, every student has to get up and demonstrate their project. And students really like that. They find it to be a lot of fun to do that kind of thing. Some are more challenged than others, but They like the overall project. So the next thing I want to show you is some of the projects. I want to show you some of the sample projects that students have built. And there are two basic kinds of projects. The first one for students who aren't really going to go on into computer science, the stuff that I teach in most of the class are all text-based. So you read in text from the user, you write out text for the user. And let me give you some examples of these kinds of projects. Now remember, when you see these are projects that were built by, in most cases, students who have never written code before. So this first one, this is a blackjack game. So there are times when I work with the students, I wrote, if anybody's into object-oriented programming, I wrote a deck object. So I took care of shuffling the deck and handing out cards. And the student used my object, and he wrote a blackjack game. So he handles all the betting, and he handles the game parts. So I'm gonna play one round of it here. I'll bet 100, shuffled 13, I'll hit 23, I busted. So do we want to play again? Sure. How much do I want to bet? I'll bet 1,000, whatever. 21, okay, so I got blacked. That was not intended. There's no special code to do that. All right, so that's the first one. And in fact, this student even extended the program. He writes out stuff to a file, so he keeps track of the hands that you've played and how much you've won. So if I sign on again, I play the game again, it'll pick up the information and start it over again. That's the first one. Second one is a hangman game. This is a very typical one. So we have a list of words at the top, and the game is hangman. So your job is to just pick letters, and the program figures out, I'm not really good at hangman. Oh, I got 2 A's. Okay. They have about 4 weeks. 4 weeks, 2 meetings each week. So it's 2 2-hour meetings each week. Actually, I think I know what this one is. Ah, it's llama. Okay. Winner, winner, chicken dinner. Okay, so another text-based game. All the input is text, all the output is text. The concepts become very, very clear when they start to use these things. A third type of game is an adventure game. And in this game, I give the students a basic, starting set of code to do this kind of a game. This game uses, if anybody's into programming here, it's 2-dimensional arrays or 2-dimensional lists. So I give them the basic part of it, and then these students built, this was actually 2 students, they built a game that where you move through this whole thing and you fight different monsters that come at you. So there's all kinds of backstory here. But the basic idea is we're moving through a world. And I can move up or down, and as I move around through this thing, here a goblin appeared. I have no idea how to play these games. I don't know what to do, but students at this school are really into this kind of game. So they really had a lot of fun doing this stuff. I'm attacking, I'm changing my health, and I honestly don't even know what I'm doing here. Maybe I'll run away. 4 is run away.
What does the 2-dimensional array hold?
It holds like a single letter, and the letter represents a treasure or a monster or a
Map, basically.
Yeah, it's a map, exactly. So I'm not going to play this game because I don't know how to play it. There we go. I get my health back, whatever. So let me kill that one because I honestly don't even know that. But they had a lot of fun doing this, and they built all kinds of randomness in it, and things show up and things go away. They really enjoyed doing that one. The second type of projects that students built is that there's a package called Pygame. And what Pygame is it's an external package that you can get for free, you can download it for free from the internet, and it's an add-on package to Python. And what it allows you to do is it allows you to have screens full of stuff. So you open a window, and you can deal with the mouse and keyboard input, so you can interact with computers the way that we typically think of interacting with computers these days. So you're moving stuff around. So let me give you some examples of those kinds of games. So this first one, I was very proud of this student. This student struggled quite a bit in the class. He really had a hard time. He was an older student. He struggled with it. It was completely new to him, but he was really motivated to do a good job. And I think he actually wound up doing a really good job in this program. So this program is called Catch the Fruit. And here it is. Fruit falls from the sky. And you have to move your basket and catch the fruit. And while you're doing that, you have to avoid the pear with the worms in it. So he's keeping track of the score and the lives, and every time you mistakenly, I'm going to catch the pear there. So, oh, I guess I didn't catch it. Here it is. Every time I catch the pear by mistake, I lose a life. But he's keeping track of the score, and when you gain a certain number of points, your level goes up. And this is a guy who had never written a line of code in his life before the class. So he was very happy coming out of this class. I'm sorry? It's very impressive. For a first semester student to do something like this was very, very impressive. Game over. So the second example is, so in my class is about programming. And I tell people on day one, I'm not an artist. I can draw a box with a word in it. And that's about my level of art. But there are some students who are heavily artistic. And the students came up to me and they said, so can we put really good art in it? I said, sure, be my guest. Do what you want. So this student did this game. And I think it came out really beautiful. So this is Cookie Rush. So she was an artist and she was into baking. So she made a game where the game randomizes, I have to talk about it first because it gives you a certain amount of time. It randomizes some ingredients, and you have to remember what the ingredients are. So here's our recipe, 4 units of this, 474387. Try to remember that. And now I get to bake it. So I have to do 4 of these, and I've forgotten it already. Whatever, I'll get it wrong. Okay, so it's some number of eggs and some number of flour and some number of baking soda. And let's go bake it. And my recipe failed, and I got a burnt cookie. Okay, so I just thought this was beautiful. I mean, she did a great job. I think she actually took her own pictures and did this. And has a restart button, and there's rollovers on the buttons. Just did a really nice job. Turns out I hired this student to be my graphic artist for my book. But so I really like that one. Another good example is there's a student who built a Chutes and Ladders game. Really interesting. So he calls it traps and shortcuts, so he doesn't get sued for copyright infringement. But the basic idea is that this is a 2-player game. So you have the blue guy and you have the red guy, and you roll dice. And when you roll dice, you move through this maze thing. And if you hit a chute or a ladder, then you move up the ladder. So the only interaction is I click on the roll button. But the program is very nicely done, and it shows off a bunch of the different concepts that I taught in class. So if you have to go through a chute, then you fall through. You just fell through a chute there. Very nicely done. And again, this guy had never done any programming before at all. One more example. Actually, I have 2 more examples. Okay, so there was one student who was really into Pokemon stuff. Pokemon, sorry. She wanted to do a Pokemon thing, and I said, fine. Apparently there's this thing called a Pokédex. So she wanted to build an interactive Pokédex. And here it is. Here's what she came up with. So you start off, and it goes through, apparently, I don't know anything about Pokemon stuff, but there's 151 basic Pokemon guys. And here you can walk through the different Pokemon. She actually had a programming class before this one, so she knew a little bit more. So you can walk through all these things. You can go to a random one, or you can even search for one. So somebody, what's your favorite Pokemon? Pikachu. Okay, actually, I remember that one. Pikachu. Okay, so there's Pikachu. So you get all this information. She actually did this with an external text file, so all this information was not in the program. She read it in from an external text file. She even did this thing, I don't understand what this is, but if you're into Pokemon, you know something about mega stuff. So there's a mega button for Pidgeot, and you can get another version of it. I don't understand it. But anyway, very nicely done. I'll show you one more. This one is one of my favorites of all the classes I've taught. This is one of my favorites. So I had this one student who was really into animation. Oh, that's the wrong one. Sorry, wrong file. And he wanted to build essentially an interactive animation project. And this is what he came up with. So the idea here is that he wanted to do animation. I worked with him and I wrote an animation object. So he explained to me what he wanted to be able to do, and I wrote that piece of code, but then he used that piece of code to build all these animations. So there's a bunch of different animations going on at the same time here. So on the TV here, there's a dinosaur riding a bicycle. There's some slug creature who's sleeping. There's steam coming off a cup of tea. But then if you click on stuff, different things happen. So this is his basic thing. This was his first one that he did was, oh, you have to click here, sorry. Click on the cake, and the dinosaur eats a piece of cake. And the text changes to say that Bob ate one of my cake. But if you click on him sleeping, then you get a different animation. He's into dinosaurs, I don't know. So T-Rex runs around, click on it again, and you get a moonwalking dinosaur. You can change the channel on the TV and get different animations on the TV. And you click on this, the face does something really weird. And the strangest one is this one here, where some weird thing comes out of the wall. And there's a little blob guy that shows up down here. There it is. So the interesting thing about this is that this guy had never done any programming before. He worked with me as a programmer, so I was his co-worker. And once we talked through how to make this thing work, he delivered all the assets in the right way. So for example, he named his files a certain way. He put all the animation, all the pictures for one animation in a certain folder. And that built right into the software. So now he knows if he's going to go get a job as an animator, he knows how to work with programmers to achieve this kind of a thing. So this is one of my favorite projects that a student did. Very unexpected, and it worked out really, really well. Whew. That's my class. So on a completely different note, I want to talk about robots. So let me go back here, and we'll talk about it.
What's the UI framework you use for the buttons and stuff and all that? What do you guys use for it? Sorry if it's not.
No, it's fine. And part of Pygame has button stuff kind of built into it, but I built my own button code. I found some button code and then I made it better. So I give my students the button code. Sorry. It's actually all built on tkinter, if you care. All right. So talked about text games, graphical games, but let's talk about robots. So I want to make it very clear that the stuff I'm going to talk about robots is not part of the Cogswell curriculum, at least not yet. So there are no classes on robots. This is stuff that I did on the side, outside of Cogswell. So when I talk to people about robots, there's typically two frames of mind about what robots really are. And most of the time I have talked to a lot of kids about robots, and kids usually think about these large humanoid things that shoot lasers out of their eyes or drop bombs and generally blow up things. Well, that's not what I'm talking about. Another group of people think about battle bots, or these big robots, real heavy robots with armor, and they have pinchers or saws or grinders, or they have different ways of throwing flames at things. That's not what I'm talking about either. So what am I talking about? I'm talking about a competition called VEX Robotics. And VEX Robotics is sponsored by a company called the VEX Robotics Company. And what they do is they have a separate entity the Robotics and Educational Competition Foundation. And what they do is they put out a game every year. They put out a challenge in the form of a game. And the job is to create a robot that plays the game. Every year the game is different, and you have to build a new robot to play the new game every year. And the hook is that you have to go buy the parts from this company. But the parts are really very good, and you do learn quite a bit about it. So what students do through this process is that they learn all about understanding an engineering challenge, coming up with prototypes, building real hardware, and then programming these robots to play the game. And I've brought some examples of it to show you here. So I worked with a team in the local area called the Green Machine, and we competed in VEX Robotics for 4 years. My sons were very involved in this, and they really enjoyed it. Oops. So, like I said, every year there's a new game, and you have to build a robot that plays that game. And the way it works is they send out a detailed set of rules for every year that explains exactly what the games are, what you can do, what you can't do. And every year teams build a different robot to play the game. The matches themselves are played on a 12-foot by 12-foot square field, and they're played 4 robots at a time, so it's 2 teams of 2. In general, you try to score some type of scoring object into a goal. So I brought one of these things with me today. Here's the idea. So imagine you're given these things, balls and barrels, and they're laid out on a field, and your job is to figure out to build a robot that'll pick these things up, lift them up 30 inches, and drop them in there. That was the challenge. Actually, in the real game, you had to be able to score them into 3 different heights of these things. So your robot has to be able to score at really different heights. And if we have time, I'll show you a video of our robot actually in competition. So the question is, what did we build? Time for the big reveal. Remember, this was built by high school students. So I was a mentor to the team, which means that I guided them in different stuff. I'm not a hardware guy, but we did have some hardware people on the team. We had hardware adults. The team was 4 people, and we had four mentors. So I was the overall mentor. We had one guy who was a hardware guy, one guy who was a software guy. This robot was originally programmed in a language called Robot C. So we had one student who was the programmer, and he did all the programming on this robot. We actually did very well with this robot. We won all the local competitions. We went to the world championships. The robot was really a good robot. The reason I'm bringing it here is because in the past 2 years, there is now a Python development environment for these robots. So if you want to, you can code these robots in Python, and that's what I did. I took the software of this robot, basically threw it away, started from scratch, and rewrote all the software in Python. So what I want to do is I want to give you an example of this robot running pure Python code. I can stick my fingers in here. So I'm a little bit worried because the table is just about the right size. I hope it doesn't fall off the edge. So I may ask somebody to, come up, just watch it, just make sure it doesn't fall over.
Security detail.
Yeah.
How much does the robot cost
How much does it cost?
altogether? Your parts?
The
Just wondering.
parts are, if you were to go out and buy the parts for this robot, I'd say it'd be on the order of $1,000.
Not too bad.
For the entire season, for 4 students, the entire budget for the whole thing was $3,000. It was much cheaper than other robotics competitions. This is the single largest robotics competition in the world. So let me see if we have connection here. Yep, we're good to go. So the way this works is I have essentially a joystick here, and I'm controlling the robot by sending stuff over to the robot. And the robot responds to the different buttons and things that I press here. So actually I have it backwards. So I try to remember which is the front.
Is it like a Bluetooth connection between your computer?
It's not Bluetooth, but it's called DexKnit. And I'm not a hardware guy. Somehow the stuff goes from here over to there. So it's these things right here that connect to each other. So the basic idea is that this thing drives forward, like that, drives backwards. It can go sideways. It can spin around. And it has, the way that it gets up to the top is through an elevator system, which is really unusual. Oops, there it is. So it's a dual elevator system that allows it to go up and down. And then we'll see if I can do this. I am really, really bad at driving this robot. So basically it works. And also the real thing runs on rubber tiles. So running on cardboard is not great, but we'll try it here. We'll see if it actually works. So I'm going to intake. This is my intake mechanism. I'm going to go forward. Whoa. And then I raise the thing up. And I go towards the goal. And I'm just doing this because I can't drive this thing real well. And then I bring these things up. And it scores. Okay. So, thank you. Now, part of the competition is that in the real competition, if we have time, like I said, I'll show you a video. But in the real competition, the first 15 seconds of the match are autonomous mode, which means the robot has to go on its own. So that's the hardest part of the programming. So I've written a whole bunch of autonomous routines for this robot. So if everything works, we'll try an autonomous routine, and hopefully it won't fall off the end of the thing here. Okay, so on the real field, things are laid out precisely, and you know exactly where everything is. About there. Close enough. All right, so I may have to grab the robot while it's running because this is a small table. Like I said, the real field is 12 feet by 12 feet, so I hope this works. Here we go. We're going to run autonomously. Okay, so that's a real competition robot that really worked, and it was a great robot. We really like it. It's 4 years old now, and it still actually runs. Let me put the elevator down. The wheels on this robot are very interesting. If you notice them, very strange wheels. These allow it to go forward and back like a regular wheel, but if you turn the wheels this way, then the robot can go sideways. If you turn them that way, it can go sideways that way. They're called Nikodem Wheels, very, very interesting wheels. And for the particular game that we were playing, we thought those were the right wheels. There's like 3 different kinds of wheels. Okay. Let me show you one more robot, and then we're done. And then I'll open it up for questions. So there is another package that's built into Python called the Turtle Graphics package. And let me show you an example of what Turtle Graphics is. So Turtle Graphics, think about if you had a turtle that had a pen, and the turtle can move around on a surface. And the idea is that whenever you want, you can tell the turtle to put the pen down, put the point of the pen down, or pick up the pen. And you can tell the turtle to move. And you can tell the turtle to rotate. So you have a very small set of instructions. Move forward, rotate, put the pen up, put the pen down. And then using that, you can build a whole bunch of different graphics. So for example, let me do this one. And And some of my students actually do this as their final project, this kind of thing. Oh, got it in the jam on. So there it is. The turtle is moving and it's drawing and it's filling things. Sorry. The turtle's moving, it's filling things in. So, as an example, I wanted to see if I could do some stuff in Python and then make a robot to do it. So, what I did was I started with the package and I said, okay, let's have it draw something. So I built a little program that just draws the word VEX. That's the name of the robotics platform. So here it is. Here we are, we're just drawing lines. And it's drawing the word VEX. Great, not so exciting. But to a new student of Python, that is a pretty exciting thing. So what I did was,
Graphics has the whole library for this.
yes, it's built in, it's free.
Seems like logo in some ways.
It's exactly like Logo. Yes, it's a Python implementation of Logo. So, second big reveal. Here is my Python-based turtle graphics robot. And the way this one works, so the way this one works is it has a pen right here. The pen is actuated by a pneumatic cylinder, the thing that pumps air and it pushes it down or picks it back up. And it's programmed to hopefully draw the word VEX. Fire it up. Let's see if it works. Remind me to take off the pen cap. Okay, so I need to switch this. To this. Okay, I have different controller kits, a different robot. We're going to do some live drawing. So I have it set up to do a bunch of different things, but this was the most challenging one, was to just write the word VEX. So it's just a series of statements that allow it to rotate a certain amount, put the pen down, draw, rotate, basically like that. And here we go. I hope it works. Oh, the marker's dried out. And as often happens in live demonstrations, the marker dried out. So didn't do it again. But you get the basic idea. Let's try this one instead. So believe it or not, my older son worked in a 3D printing place and 3D printed these little clips here, so it fits exactly on these things. I think it's actually going to work. Let's try it again. It's slipping a little bit on this surface because it's normally designed to run on rubber tiles. Well, it slipped quite a bit.
It's skidding.
It's skidding. But there's the, upside down, but there's the V. There's supposed to be the E and that's supposed to be the X, but it really slid on the surface. But you get the basic idea. So the interesting thing about this is I built this as a demonstration piece for a potential class. So maybe someday I'll be able to do a class on robotics. I'm going to have to have two more caps. One. The other one's right underneath. very object-oriented approach. There's different objects dealing with the drivetrain, dealing with the pen system. And I built this framework in a style called object-oriented programming. And someday I hope to use that here in a potential class on Python. That's all I have. So I'm open to questions. And if you'd like to see the video of this robot in competition, I can show that. Like to see that? Okay. I have that here somewhere. Here it is. Okay, so the team back here, this is my team. That's my son. And the match starts off with autonomous mode. And like I said, this game changes every year. So this is from the World Championships 4 years ago. So there's 9 of these goals around the, there are 9 of these goals around here. This is the autonomous mode. The robot's running on its own. You are allowed to reposition it. So we're repositioning the robot to score more points. The rules are very complicated, but the basic idea is you pick up these balls and barrels and score them into these different goals all around the field. And the more you score, the better it is. You get extra points for getting the first one in. So we are playing, so this is my team, we're playing with this team. We're the Blue Alliance. We're on this side of the field. The other side of the field is 2 other teams. That's the Red Alliance. And the basic idea is you have to score more points than the other team. So we're doing well. We got this big stack in the center here. We scored over here. These gates open at some point. And so there you can see how we're scoring on different sides. The gates open and we decide to go over on that side of the field and go score over there. And you can see how these robots are all different. So the idea is that you get this challenge and it says, use our parts, build a robot. They don't tell you how to build it, you build whatever you want to build. So we're scoring over on the low goal over here, and then we're going to score somewhere else. But a really cool thing happens at the end of this video. I don't want to tell you too much. So at this point, we're actually feeling pretty good about our match. We think we're going to win it, so we decided to start scoring for the red team. So we picked up one of the red things over here. So we're going to score a red and a blue at the same time, so you can see the elevator going up. We're scoring a red and a blue. And now comes the interesting part. In the last 30 seconds of the match, in this game, you can introduce a special barrel called the black barrel. And if you watch on the left side over there, this guy's going to introduce the black barrel. And the black barrel allows you to negate any ones that have already been scored. So here he comes up. He's going to score this big black barrel to get rid of our whole stack. But we recognize, we expected that. So we shoot out this thing, remove it, and then we put a white barrel that doubles the score. And the crowd went wild. That was our single best moment in all of robotics. We prepared for that moment. It was, we knew it was coming. It was a print statement, that's right. We used a print statement there. So again, this was not done in Python. This was written in Robot C. I have one other video, unless there are questions. I'm open for questions.
So what, does VEX provide a Python library in some ways, or you had to do everything from scratch, or like what was their approach at that point to, because I think the most difficult thing would be to do the whole I/O stuff in Python, or was that?
The way that it works is there's a company, a separate company, not VEX, but there's a separate company in Washington called Robot Mesh. And they've done all the work of supplying the library that allows you to connect to all the different devices. So you make a call. So think about it this way. In the programs that I showed you, the text programs, you're typing on a keyboard and your output goes back to a screen. In this environment, instead of typing on a keyboard, you're listening for keys here. Right. So the input, you just sit and you wait for a command to come in or a button to get pressed. The output, instead of writing out text, you write to a motor. So you say, tell that motor to go 50% or 100%. And you can address each of the individual motors separately. So So that's how we can make it, so when we want to go sideways, we tell one motor to spin this way and one motor to spin that way, and the other motor to spin this way and the other one this way. So all that communication, all the low-level stuff is already done.
Okay.
So you just say, write to a motor, or you say wait for an input from the joystick or from a sensor on the robot. So the robot, I forgot to mention, the robot does have some sensors. It has a thing called an encoder that tells you how many turns there are, so we know exactly how far the robot's gone.
Okay.
There's also an encoder on the elevator that keeps track of how high the elevator is. So all that stuff's done.
Okay. And this is just over USB to control it?
Yes. So this is actually this is a fake USB. It's a network that's essentially USB. In fact, to do the original programming, you have to get a USB to USB cable.
Okay. No, I meant to connect to the computer.
Oh yes, to connect to the computer is also just USB. Yep. Yeah.
Are there any companies or applications that either industrial robots or commercial robots that use Python?
I'm sure there are. There's one that I know of for sure. It's called, what's it called? Electric Movement in Mountain View. They do all their stuff in Python. I know there are other ones, but I just don't know who they are offhand. But I know more and more of them are using it. The general thing about Python, one thing I forgot to mention is that Python is slower than these other languages. If you write the same code in Python that you write in C, the code will run slower. And there's a good technical reason for it. It's because Python is what's called an interpreted language as opposed to a compiled language. So the code that you write in C will run faster because it will run on the machine that you're writing it for. Python, like I said, will run across all different machines. You can take the same code and run it on all different machines. So the code runs a little bit slower. The good news is that you get an increase in productivity, a huge increase in productivity, something on the order of 10 times. So if you want your code to run faster, you'd probably write it in C, but it would take you longer to write it. So people who write in Python generally are much faster at bringing things up. So people do a lot of prototyping in Python. They do a lot of proof of concept stuff in Python. And then if you're really worried about speed, then you might recode stuff in C or C++ or Java or something else. But I know there are other companies, I just don't know who they are offhand. But if you look at job listings, you'll find Python is used in a lot of job listings in the Bay Area. Any other questions? If not, I have another video I can show you. Okay, I'll show the video. Do we have sound connection, or can I just crank up the sound on my computer?
We do that where our fingers are crossed. Told how to do it.
Can I just plug something in the headphone jack here?
For the autonomous site, was it just fixed points? Or did they figure out where the ball
No, there's no, I understand the question. There's no vision stuff in the robots. It's fixed points. It's distance, rotation by angles, but it's not vision.
Do you know which one is your out and which one is, that's headphone.
Yeah. So as part of this VEX Robotics tournament, not only are there these on-field competitions, but there's also a number of off-field competitions where you're allowed to do writing or different types of projects and turn them in for competitions. And it turns out, we didn't know this at the time, but one of the guys that joined our team was heavily into video production. He was really good at video production. So we decided to take a shot at one of these competitions. It was the educational video. So we submitted this video to the educational competition.
I think you're going to just have to do it off of that speaker because it's not going through to.
Okay,
Yeah.
I'll just crank it up.
Crank it up.
All right. So this is, the basic idea is you're supposed to create an up to 4-minute video to teach other robotics teams something about robotics. So imagine you're a new robotics team, you want to learn about robotics, create a video. That's all the guidance that you have. So here's what we built.
Brought to you by the Green Machine, the excellent robots of 2010.
How can I make my VEX robot strong? The answer lies in a simple polygon known as the triangle. Here are the great big metal scraps of science. Check this out. Look at this. I have 4 perfect right angles, but it has almost no strength. All of its strength is dependent on the strength of its 4 corner joints, and this is really just a flexing parallelogram. But look at this. I still have the right angle, but I cannot bend this. In fact, triangles are so strong that they've been used as structural elements for large projects around the world. They've been used in the Eiffel Tower, the Eiffel Wall, and even bridges around the world.
It's in Mountain View.
Triangles are used everywhere, in everything for their rigidity. You can search anywhere for stronger two-dimensional shape, but you won't find any. They're the greatest, they're the strongest, they're the best.
We started competing in VEX in 2010, playing the game Roundup. Let me show you a little bit about our robot.
This is the first one we built. It's our first year.
In our Roundup robot, we tried to use right triangles wherever we could to keep our structure stiff and at right angles. For example, these right triangles here help keep our elevator perpendicular to the base of the robot. Want to see what runs?
So in this game, you had to pick up donuts and put them on posts. Or remove them.
Back in the 6th century BC, a man named Pythagoras came up with a theorem that became known as the Pythagorean theorem. It stated that in a right triangle with legs length A, B, and a hypotenuse length C, A squared plus B squared equals C squared. One common set of lengths used in Pythagorean right triangles is 3, 4, and 5. 3 squared, 9, plus 4 squared, 16, equals 5 squared, 25, and the triangle must be a right triangle.
You can use Pythagorean triangles in your robot too. Just find a set of side lengths that will work with a right triangle. For now, we'll just use 3, 4, 5. Wait a minute, this isn't a right triangle. Alright, I figured out the problem. So, the distance between the first hole and the second hole is ½ inch, and the distance between the first hole and the third hole is an inch, and so on. So it's really the distance that matters, not just the number of holes. To avoid this, you should start by counting from 0. Look, this triangle works.
If you're a C programmer
0, 1,
or a Python programmer.
3, 4, 0, 1, 2, 3, 4, 5, 0, 1, 2, 3. So it's a 3, 4, 5 right triangle. Try it! Try it!
Today I'd like to give you some interesting tips on how to make your robot stronger. A lot of the times when you build your VEX robot, you're going to want to have a rectangle. But unfortunately, rectangles by themselves are very weak. So, instead, what you want to have is a diagonal crosspiece, which makes 2 right triangles, which makes the whole thing much stronger.
Well, that's our show. Thanks for watching. Now, if you'll excuse me, I got some robots to go build. See ya.
So we submitted that video, and we won first place in the world for that video. We won a gift certificate for $750 for buying new equipment for our robots. That was done, was edited by the guy who was the nifty home experiment kid. He was a freshman or a junior in high school when he did that. He did all the video editing. We were blown away by what he was able to do. So if you've ever seen a Bill Nye the Science Guy video, it has all those elements from a Bill Nye the Science Guy video. And the people at VEX really liked this thing. We went to the World Championships, and they were playing this thing over and over in this big auditorium, and it was really a great experience for the kids. That's my show. Like I said, I'm open for questions, or if not, thank you for coming. You're welcome. Thank you. Hi.
Sorry, I missed most of your presentation.
That's okay.
Stuck on the 237.
It happens.